The top 25% are the most variant. Which ones are the least variant? I think this guy down here is actually the least variant. It might be helpful to actually put another line at the min and the max, like that, to get a visual. And you can see, oh, this is the tightest, that's a little bit wider, and most wide. And that's great, except for the fact that nobody actually does that. There's a type of graphical display that actually shows this much better, called a box and whisker diagram. So what I want to do is I want to chit-chat about that right now and add it to our dot plot. So we got our dot plot, and it's beautiful, and I don't want to lose it. But what I want to do now is I want to add, not a histogram, although we can do the histogram later, I promise. We'll put the histogram up on the TI. What I want to do is I want to take out all these vertical lines. I'm going to do without erasing the data. And I want to add what's called a box plot or a box and whisker on top of this. And what it basically does is it ties in these values plus two other ones, which we'll get back to here in momentarily. But these three, we're going to start with these three. Why is it called a box plot? The first thing is we're going to add a box, and that box shows the quartiles and the median. So what we're going to do is we're going to find those two quartiles, 9.5 and 22.5. We're going to slap that there. We're going to draw a box from Q1 to Q3. You can label them if you want to. You can put the actual numbers on there, but I think it's almost sensible not to because you have the scale down here. And if I was a good statistician, I'd actually have a label on that. So I feel better about myself now. Number of states. Within that box, slap in a median. The median is 14.5, so that's going to go right there. So what is that box showing you? What is that box showing you? Where your two quartiles are and your median. What else is it showing you? What percent of your data? What percent of your data is it showing you right now? Mimi, go for it.
50%.
Half of it. The middle 50%. Perfect, my friend. This is analogous, if you will. If you're looking for an analogy to where we just were, when we were talking about absolute position of mean and standard deviation, one standard deviation traps 68% of the data. Two standard deviations trap roughly 95% for bell-shaped data. This is like an analogy to that. It's not bell-shaped data necessarily, but what those two lines show you is where half of your data lives. What does this part right here show you? I'm sorry, let me ask you a better question. What percentage of your data lives in here? 25%, right? 25%, right? Now, Trevor brings up a good point. I'm using the word 25% in an ish capacity. Sometimes it might be 24.5-ish, 25.5-ish. It depends on how the data set chops up. This one chopped up perfectly. So exactly 25%. But it's always 25%-ish of your data lives in that data set. You'll see what happens when maybe we get nastier ones starting next week. And by nasty, I mean interesting. They are interesting when they're nasty. Okay? What percent live here? Again, 25. Which of the two 25% of those data sets is more varied? This guy. And you can tell that by the width of the box, right? Could you tell that over here in the raw data? Is it obvious in the raw data? No, not at all, because it's just raw data. There's always a problem with raw data, visualizing raw data. It's always better to have it, because you have every bit of precision you're entitled to. But it's always a problem when you're trying to get ideas. Is that data skewed? I have no idea. I can't even see it right like that. That's why this kind of an idea looks good. All right, let's come back here. Now that's the box part of the box and whisker diagram. The whiskers are what take care of the other 25% of the data. So you draw a whisker down all the way to your lowest data point. Now our lowest data point was a 7. So we're going to draw that whisker down to 7 and put a little bow tie on it if you want to. And then you're going to draw the other one up to 41 and put a little bow tie on him. And that, my friends, is a box and whisker diagram or a box plot. You get a beautiful visual of spread. Now, without the dot plot, you lose the individual data points. But as the lady just correctly pointed out, you still can see how spread out the data points are. And you can make an assumption about it. You can see this spread, and you know what? I'm going to assume they're spread uniformly. I'm going to assume, and you know what? They pretty much are. Look. They pretty much are spread uniformly. It's not like you've got 4 data points right here at 41 and nothing else down here. Well, actually, if you did that, the median, the Q3 would be up here further. But the point being is that generally the data points spread out. Now here you got a little bit of a goofiness. You've got 2 at one and a 2 at the other. But again, that doesn't happen super frequently. On average, things spread out through the intervals. On average, they spread out through the intervals. Small data sets have all kinds of weird misbehavings.
From this particular thing, can you also figure out at least, or does it show us standard deviation?
It doesn't. Very good question. Very good question. A box plot is purely a measure of relative position. So you're getting those cutoffs and percentiles. Some folks like to put an average on box plots too. So for example, this 17 states will be indicated by some other kind of a line, like, I don't know, like a diamond right here or something like that.
Actually, it will make sense.
You could put the standard deviation if you wanted to. You could put, for example, you got 10 states here. What the hell? You know, it's a bit different color too. Only write this down if you don't think it's going to confuse you.
With average, it makes sense. I mean.
So there's your average of 17. Plus or minus 10 would go down to 7, which would be down here, right? I shouldn't use that symbol. I'll draw a bar. And then up to 27. That would be 1 standard deviation from mean, right there. 2 standard deviations would bump out 7 more on either side. They're not usually indicated on box plots. Now, does it upset anybody that 1 standard deviation is wider than the box? Does that upset anybody? I know it's too early in the morning to be upset by anything right now except lack of food. But no, John, Ryan, not even close. Damn it, same number of letters and ends at the same letter. Okay, close-ish. It doesn't upset you, Ryan. Why?
I don't remember the number, but the empirical rule says like 65%.
60, yeah, 2/3-ish, 65 2/3. Even if this data were bell-shaped, we'd expect 2/3, which is more than half. So don't be upset if that standard deviation is wider than the box, because generally it's going to be pretty much. You got it, my friend. You got it. Fair enough-ish? Fair enough-ish. Okay. This is great. You're seeing everything you need to see from the data. I never want you guys to have to calculate these again manually, okay? Because there's really no need. Dot plots, your TI doesn't do a good job with dot plots. We can get close to a dot plot on your TI. We'll finagle that here momentarily. But I do want to show you how to get these beautiful things called box and whisker diagrams on there. Box and whisker, or just called box plots. So, what I want you to do, friends, is I want you to turn your machines back on. I want you to leave that histogram you just made on for the time being. Okay? But what I want you to do first, pull this down momentarily, fire this up. All right, Robin, you're back on deck, my friend. There's our beautiful graph. Could you all please run 1var stats again on our beautiful state data? If you'd be so kind. Run me some 1var stats. Go ahead. Muy perfecto. Average of 17 states, plus or minus 10, and we're happy with that. But we're not going to look at him right now. We're going to ignore him. I'm not saying we don't like him. I'm saying that right now we're going to focus on something else. Scroll down. The last 5 numbers you see are called the 5-number summary. Any of them look familiar? Hell yeah, they do. 3 of them look familiar. Your median's right there at 14.5, which we calculated. Your Q1 at 9.5 states, which we also calculated. Your Q3 at 20, which we also, I'm not bragging. I am bragging for us. What the hell, you guys are awesome. We are bragging. So what it also gives you is it gives you the min and the max values of your data set, even if they're not sorted. So what the TI has just done is it's given you 5 numbers, which if you recall, goodness gracious, it's a party out there. It's a stat party. The 5 numbers are the ones you needed for your box and whisker. Those are the, like I said, it's called the 5-number summary, and it's just one way of, again, I'm trying to say synopsizing. That's not a real word. Summarizing. Thank you. Summarizing a data set. Although the visual I still think is better, because if I asked you, well, okay, those are the 5 numbers that divide your data set up into 4 equal percentage pieces. So 25% of your data is here, 25 is here, 25 is here, and 25 is here. If I ask you a question right now, which of those 25% is the most varied? You have to do like mathematics to figure it out, right? You have to look at that and go, okay, which is wider, this, or this, or this, or this, or this, or this. It's not hard math, it's attraction. But it's nice to get that visual. So let's get a visual. Second y equals on the TI again. Second y equals, leave plot 1 on. So leave plot 1 as the histogram. Go ahead, Robin, hit y equals, my friend. Top left corner. There you go, awesome. Leave plot 1 as the histogram, okay? Go down to number 2. Go ahead and press enter on that one. Turn that bad boy on. Okay. Oh, make sure you press enter. You have to press enter on it to turn it on. There you go. Perfect. Now, there are 2 box plots. There are 2 box plots that are indicated in this screen. So jump down to the next line. Go up one more. There you go. That's called a scatter plot. We'll deal with that in 244 when it makes more sense. That's called a frequency polygon. We don't really deal with that in here because histograms take its place. That's a histogram. So arrow over a couple, arrow one more. That's called a modified box plot, which will show outliers. The next one over is a non-modified box plot. Select that one for now. Select that one for now. I like the other one better, but I want to be careful about defining an outlier with you guys before we have outliers kind of clear in our mind. We'll come back to that on Monday, I think. And this you can ignore. We'll deal with that in 244. Okay, scroll on down. Where is your X list? I.e., that's TI, where is your data? Be brave, you know. It's an L1. You got to change it, be brave. How about your frequency?
So, alpha.
What's your frequency going to be? 1. It's just going to be 1 because you got raw data. So change that bad boy to a 1.
Alpha 1.
Stupid. Why? I hate this TI. What do you have to do? Robin's going to fix it right now.
I'm going to try.
You got it. Green button. Green button. There you go. There you go. There you go. Now, just press graph. Just press graph.
That's what I screwed.
Boom! You get the histogram with the box plot, which is super slick. Which is super slick because this tells you so much about where your data is. We get the same cool relative perspectives of the box plot that we got before. So, tighter, not quite as tight, most varied. You get the visual of most varied by dropping it down and saying, oh my goodness, look at where all these bars are. These bars are super wide. Then you look over here. What percent of your data live right here, friends? What percent of your data live right here? 25%. And when you drop that down, you're like, holy crap, that's 1 bar where they all live. Just so you know, there's one reason our hand-drawn graph exceeds the cool factor of this TI-generated graph. And what is that one? What is that one feature that our graph has this one doesn't? And this pisses me off a lot about TI's lack of graphic capability.
It doesn't have the numbers on
Jane, it's nice and loud, my friend.
it doesn't show the values or
There's no numerical scale.
Yeah.
We know because we set it up. 0, 5, 10, 15, and so forth and so on. We know that because we set it up to be that way. It doesn't show that. This pisses me off. But we have a workaround. Press the trace button, which is the only button in the top row you haven't pressed today. Right now, if you look at your TI, it says P1:L1. That means you are now on plot 1. Now check out, it's a little bit TIEs, but make peace with it. Right now, it's saying, okay, min 0, max less than 5. That means it's counting the number of states that are at least 0, but less than 5. Nobody has visited that number because our smallest number was, do you remember? 7. Arrow over 1, Robin. Arrow over 1. Now, it's counting the number of people that have been to at least 5 states, but less than 10. There are 4 of them, because 2 of you have been to 7, and 2 of you have been to 9. So there are 4 total. That's why that bar is 4 total. And you can arrow over again, and so forth and so on. We continue on and counting all the data sets. That's all that's doing for you. How do you get onto the box plot? Go ahead, be brave. Up arrow, Mimi. Up arrow, Jen. So up arrow, Robin. There you are. Now you're on your box plot. And you can scroll back and forth. Go ahead, Robin. Explore the right and left. There's your quartile. There's your median. There's your upper quartile. There's your max out there at the end. So this is kind of acceptable for not having the scale on the bottom of the TI. You can still get the scale by jumping around. Fair enough? And by all means, you can mess with the scales. But one last thing. Robin, if you would, press the window button one more time. That's the second button over from y equals. Yep. Would you go down to X scale and change it to, let's see if it'll do this. X scale, X scale, go up. It's got a 5 in it right now.
Oh, right there.
Yep, X scale. This is going to tell you how wide each bar is. Change it to 1, and let's see if it'll let us graph this. Go ahead and hit graph. Yeah, I don't understand the rules of X scale as it deals with statistics. Go ahead and hit quit.
Okay.
Can you go back to the same button, window?
Oh.
Just press window and change X scale to 2. And now press graph. This should work. There you go. Same exact data set, but now instead of going 0 to 5, 5 to 10, 10 to 15, it goes 0, 2, 2, 4, 4, 6. Exactly, there you go. Right there. Perfect, Robin. Awesome. So keep going. There's your 7s. There's your 9s. There's your 11s and whatever else. We got 10s and 11s and so forth and so on. It's almost a dot plot. Almost. A dot plot would be perfectly 1 wide bars. But I like this too because you know that from here to here there should be exactly 4 data points, and here they are. Those 4 are in that. These 4 are in that one. These 4 are in that one, and these last 4 are over here. Now the reason I like dot plot versus 2 wide is some of those bars are shared. Like this bar right here is partially here and partially here. But again, that's data. As data sets get larger, that becomes less of an issue. Yes? Makes sense-ish? We'll do more of this on Monday. More of this on Monday because I know we're going to forget a lot between now and Monday. And that's okay. Understandable. So for Monday, just work on the take-home part of your exam. Email me if you get stuck. I'll be checking email over the week. I'm at a math conference all weekend, but I'll be checking email quite a bit. So.
Do we have a quiz due Monday too?
I put it on Wednesday.
On Wednesday?
I just put it up this morning. I put it on Wednesday. I didn't want you to have 2 things due on one day.
And then should we bring homework for Monday?
No, don't do the homework for this yet. No, I want to play. I should probably turn this off before I start yelling.